Now, many IoT devices have small memory, limited processing and communication capability, and they are also battery operated. Naturally, IoT requires integration of multi-technology networks to a common IP network platform, and a common IP network platform is the Internet, which is the Internet of Things, which is the IoT concept we are studying about. Then, IPv4 and v6, because it is the Internet, this is the blood, this is the ingredients, this is how the components, the blood cells of the Internet is actually running on IPv4 and IPv6 packets with routers and routing tables inside the gateways. This is what is the operational mode. And having Internet of Things means that you're going to connect things to the Internet. Naturally, you need to use IPv4 and IPv6. Now, I have a separate course that is called Introduction to TCP/IP. Details that are useful to you on IPv4 and IPv6 and the Internet, and TCP and UDP are all included in there. And I highly recommend for you to take that course if you're interested in further details on this. Now, IoT will have significant influence on future Internet architecture, and that is why we need to study this in detail. IoT services must guarantee the security and privacy and integrity of information user confidentiality. Now, because we have sensors around us, and we have sensors on us, as in terms of wearable IoT devices, then our personal information and all that we do may be recorded. And if somebody gets control of this personal information, we can be harmed both physically and financially in various ways. That is why confidentiality is so important, because IoT information is about us. Some key features in the research and development, R&D, of IoT include things authentication and authorization and user authentication and authorization. Before you allow a certain device to use your network, you need to make sure that it is an authorized device, and you need to check it. You need to authenticate it. Because what if it's a hacker device? What if it's looking just to find a way to validate its access to the network and then attack you through ransomware? What are you going to do? What if it provides denial of service features? What if it's hacking? What if it's going to compromise your unit? So therefore, you cannot allow anything to be connected. You need to authenticate it, and then if it passes authentication, you need to authorize it. And when it's authorized, you need to give its authorization level. This thing is going to get access up to this much, up to this range, and it can access these databases, but not more. User authentication. Of course, things need to be checked and authorized, but then people need to be checked and authorized. IoT public and private key management. Public and private keys are used to govern authentication and authorization, to make sure that things that are protected are encrypted, and they can only be opened, decrypted by authorized users. Thing-to-thing access control. Remember in my former lecture, there was machine-to-machine communication, which was connecting thing-to-thing. That was one big domain of the IoT domain, which other options, we had human-to-thing, and we had thing-to-human, or we had human-to-human. These type of other options did exist, as in terms of the things were the machines. So we had H to H, we had H to M, and M to H. And the M to M, machine-to-machine communication domain, was the largest. This alone consumed approximately about 45%. Then there's low overhead protocols and low complexity processing. You will see that we will talk about some wireless personal area network technologies and other low power, low processing capability devices and techniques that are used in IoT networks that are focused on this specific objective, such that they have a very long lifeline, they go on very long, but they're doing a specific task the right way. Mobility support. Once again, for the sensors that are on you, like your smartwatch, your smartphone, your smart tablet, your smart belt, your smart shoes, your smart glasses that are supporting augmented reality, well, they're going to move with you when you move around. So all of these devices need mobility support. The network needs to switch you over to different places such that you are consistently receiving services wherever you go, and your connecting points are switching over, and the network needs to support that. Then, it needs to be changed and upgraded and switched over, not only the connection, but the overall end-to-end data flow from your device to the other server, your device to another person. That needs to be connected through the entire way. So mobility support in a small scale, as in terms of your small wireless switching at the edge of the access point to the mobile communication base station, to your Bluetooth point, to your Zigbee access point or master node, to the backbone network and all the access network switching over together to provide you with seamless, non-disconnected services all the way. Mobile platform-based IoT enables enormous range of future applications. It is very difficult to support, but then again, once you get it working, it has so much extra value. Location-based services, LBS, can be supported. Social networking from anywhere and anytime. Environment monitoring and interaction, all of this becomes possible with IoT mobile support. Energy and resource management, so important. So, energy issues are related to optimization of energy harvesting, conservation, and usage. And these are essential for IoT development. What we're talking about here is energy harvesting. What is that? Well, think of it this way. A lot of devices have various energy resources around them. Light sources that they can charge from. Some can use wind. Some can use radiation from microwaves or local Wi-Fi components or mobile communication signals that they can whatever pick up and save and charge themselves. In addition, a lot of wireless charging techniques are available now. In other words, wireless charging pads that come from various vendors. These are available. And as wireless charging remote techniques become more and more possible, you will have multiple opportunities to charge the battery of your IoT devices. Then you want to save that energy and then use it when you need to use it. That is what we're talking about energy harvesting. Number one, you do not use energy that is going to be wasted. Whatever you have, you use the minimum amount in the most conservative way. Number one. Number two, whatever opportunity you can charge, you take advantage of that and you charge. And then number three, you save it and use it just when you need to. That altogether is what we talk about when we're looking into the research and development of IoT focused on energy harvesting. If you are interested in wireless charging techniques through wireless charging pads for IoT devices or smart devices, then please consider to study the Smart Device and Mobile Emerging Technology lecture that I have in this specialization. In that course, wireless charging techniques, wireless charging protocols and standards are discussed in further details. It is also important to consider resource restrictions, wake-up delays, power consumption, battery capacity, packet sizes. All of this needs to be considered in IoT research and development. Identification techniques. IoT devices produce their own content. Contents are shared by any authorized user. So identification and authentication technologies need to be converged and interoperated at global scales. This is because you have one device on one side of the world communicating to another device on the other side of the world, or somebody on the other side of the world. So therefore, authentication protocols here may be different there. In addition, authentication protocol on this network may be different from that network. And once again, since Internet of Things is about connecting things and people on the internet, which can be located anywhere in the world, most likely the protocol here and the protocol there will be different. The authentication here and authentication there will be different. The authorization here and the authorization, as well as the policy there and the policy here, will be different. That means that eventually you need to have some convergence and interoperability supported. Management of unique identity of things, definitely needed. This is a part of what needs to be authenticated. Handling of multiple identifiers for people and locations, obviously that is necessary.